let's try and figure out the uncertainty and the velocity. We've done these propagation of error problems before, and this is no different. And eventually you'll get the hang of it, but you just have to practice doing these things. Velocity is pretty easy to find the uncertainty in. You only have two things, so you're only going to have two things underneath the square root sign. Of course, we need t and delta t, and we need d and delta d. So we already have d, 0.015, and its uncertainty, which is plus or minus 0.0001 meters, 0.001 meters. Now we have to find the same thing for the time. So we have to find the average of time. So first, place your calculator in stats mode and find the average and standard deviation of your time values. So I'm just putting them in right here. Hopefully I plugged them in right. And you guys can check me. And what I'll ask you to do is stop the video when we're oh, and I'm missing one. There's an extra 0.0064. Sorry about that. Okay, 1, 2, 3, 4. So I'm on 0.0067. 0.0067. And then 3.0064s. So you can stop and you guys can write down the average and the standard deviation, and then you can play once you're finished, because I'm going to write it down right now. Now, remember the standard deviation. Let's see if you guys wrote down the right standard deviation. There's a sigma n and the sigma n minus 1. Remember, we want the sigma n minus 1. That's the experimental standard. That's a sample standard deviation. If it looks slightly different, you probably wrote down the wrong standard deviation. So on a lot of your calculators, the experimental or the sample standard deviation, geez, that looks like that's a 6. It looks like an S, and the regular one looks like a sigma. You may have a calculator with sigma n and sigma n minus 1. The sigma n is if you take like an infinite amount of data points, but we didn't. We only took 10 data points. So we use a sample standard deviation, which is sigma n minus 1. You have to correct for the fact that you're not using the full set of data. Now notice the precision of the instrument, or the least count, is plus or minus 0.001. This is higher than that. It's 0.0002. So it's about twice that of the least count of the instrument. And again, it depends on the data we're taking and how noisy and random error, how much random error is present in your data. So if you only took one of these data sets, your uncertainty would be 0.0001. However, in science, you always want to take lots of data. So, and that's so that you can get a better grasp of the uncertainty in your measurement. So now we're ready to actually find the uncertainty. Well, first we have to find the velocity. So the velocity is distance over time, d over t. D is 0.015 meters divided by 0.00665. So go ahead and calculate that out. You can stop the video and you guys can write that down. And then I'm going to write down now. Hopefully you have stopped it. I got 2.26. All right, so recap it to 3 significant figures. Now, how I found the error in that. So this is distance over time, so there are going to be two things underneath. First thing you write down is the velocity itself. The square root is the percentage, so it's percentage times the v. So I'm actually writing down what's called the absolute error. So we have delta d over d squared plus delta t over t squared. So remember, whenever you set these things up, I mean, I know it seems complicated, but it really isn't. When you're multiplying or dividing, you divide them by two things. You just stick them in there. One thing and the second thing. Always delta over the original thing. So v is 2.26, so just plug it in. And delta d, that is what do we use? We use the ruler, so that's a millimeter, right? So it's 0, 0. So a millimeter is this point right here, so it's the third over 0.015 squared plus delta t, which is 0.00019, divided by t, 0.00665. And that's it. That's the error in the velocity. The uncertainty. The uncertainty of measurement in the velocity.